welcome to today's episode of The Square. I'm here with Brent Rollins, who's the VP of Business Development for Spraylock Concrete Protection. Now, we're going to be kind of talking a lot about concrete. We're going all in. It's not, when I first started doing a little bit of research on this, it's not the super sexiest topic.
No.
But it's so prolific. I had no idea. Concrete is the second most used resource, second only to water in the world.
Yes. Yeah. In fact, there's so much concrete used every year. It's somewhere in the neighborhood of 30 billion tons a year or something like that. It's amazing. So, in fact, to put that into perspective, if try to wrap our minds around it, if you were to build a sidewalk 4 feet wide by 4 inches thick, you could wrap the earth at the equator about 880 times with the concrete that we make every year. Yeah.
Every year.
Yeah, every year.
So it's a huge potential that if we can modify or tweak how we make it, we can have a massive impact on the environment.
Sure. So, in fact, things like LEED and other green initiatives have been part of the concrete world for a while. Looking for ways to do things like increase the recycled content that's used in the concrete, or make sure that we use regionally sourced materials, and those kind of things are all things that the concrete industry is very much aware of. There are new initiatives, however, that are becoming more and more prevalent in the industry because environment is important to so many people.
Tell me a little bit about how you got started with concrete. It started with a car, right?
Yeah, it did. So, yeah, I was 16 years old. I was a teenager, and like most American teenagers, I was looking for a way to get a car to get around town, And so I had to go to work. Yeah. And I was looking for a job in a nice air-conditioned space, like a bookstore, movie theater, like a lot of my friends had. But nobody was hiring. So the last thing I wanted to do was to go to work in the concrete industry. My dad was in it, and I had seen the kind of hours that he put in. And, it's dirty work, it's sweaty work.
Hard,
That I didn't think it was for me.
Yeah.
But that was the only place that would hire me that summer. So I went to work loading building material customers in the warehouse, the hottest part of the entire job, and
in South Georgia.
I mean, it was super hot. But from that, the laboratory manager needed some help one day. He had hurt his back, and he needed some extra grunt labor, to help him in the lab. So I began helping him in the lab, running tests on concrete, figuring out or learning how to do all of the quality control type testing.
Yeah.
And shortly after that, I got a chance to be involved in a project. I was inspecting every load of concrete that went to the Northwest Georgia Trade and Convention
every load that left.
Yeah, at least visually. I was testing physically, running slump air unit weight tests about every fifth load, and then but every single load would have my eyes on it to make sure that that visually that truck, that slump looks good. It's not too wet. It's not too dry. I can send that truck. So to make a long story short, we completed the project toward the end of the summer, and I had not set foot on the project site. I'd done all this work at the laboratory and at the concrete plant because I was only 16. Right. I couldn't go to the project because of insurance reasons or whatever.
Absolutely.
So the sales guy brought me by the job. He asked me to come by and see what I'd been a part of. And man, when I pulled up on that job site for the first time, I happened to show up the day they're tilting tilt wall panels.
Oh man.
And it blew me away.
You got to see all your work.
I got to see all my work. I got to see every piece of concrete on that site had at least my eyes on it, and didn't come to the site unless I said it was okay to go to the site. And it was overwhelming because it hit me. I'm a kid. I'm 16 years old, and yet I had a part in this building.
Yeah. And
this building wouldn't be here if it wasn't for me. That was what came to mind. But that's what hooked me, man. It was instant job satisfaction, and that continued to fuel my career. And I think it led to really wanting to understand and learn as much about concrete as I could. It's a very complex topic. Most people don't think so.
That's what when we were talking earlier, you mentioned there's hundreds of elements that go into making concrete.
Yeah, so it starts with Portland cement, and that Portland cement is the binder, the glue that holds everything together, if you will. That's the way a lot of people refer to it. But that Portland cement can have 150, 160 chemical variables alone. Wow. And not to mention mechanical variables such as particle sizing and things like that. So the coolest thing about concrete for me is it takes the ideas and the subjects of chemistry and physics and engineering, and it's all rolled into one material, because if you want to understand concrete, you have to understand how all of those little variables interact with each other. And the great thing about concrete is that no matter how much you know, there's always more to learn. Yeah. And that makes my job a lot of fun.
Now, despite your love and falling into the concrete industry, if you'll excuse the bad pun, you actually took a detour in college.
9/11, I made a decision when 9/11 happened that I was going to do something, and I didn't know what. So I went back to college to study Homeland Security. Mm-hmm. I earned a 4-year degree in Homeland Security. Toward the end, the time came to choose a career kind of path. And I had a 4.0 grade point average in the Homeland Security program. And I was looking into going to work for the government somewhere. And what I was finding was that I was putting my wife through college at the time as well. And we didn't have a lot of money, but the concrete company was paying me okay.
Yeah.
And none of the entry-level government jobs were anywhere close to what I was making. So I'm going, oh my goodness, what am I going to do? And I talked to my advisor, and my advisor said, Brent, why don't you use your concrete experience and use your now Homeland Security education, marry the two up, and specialize in protective structures. And it was a light bulb that went off, and it became my new why story. It's what I wanted to do, was to provide additional protection for things like embassies.
Yeah.
And pursuant to that, I got, after getting the degree, I had the opportunity to go to the University of Tennessee at Chattanooga, where I was a researcher. I was the director of the Civil Engineering Materials Research Laboratory. So that meant that whatever I wanted to play with concrete, as long as I secured funding for it, then the university wanted me to research it.
Yeah.
And that's where I first ran into the next stage of my career, which was the colloidal silica product and the effects that it can have, the improvements it can have on durability and permeability. So the shift is still the same. The focus is still the same. I'm still very interested in helping concrete structures last longer. Mm-hmm. Whether the source of its shortened life is man-made or the environment.
Sure.
So when we talk about resilience, we're talking about resilient concrete structures that are resistant to loads, they're resistant to the environmental effects, they're resistant to intentional acts to try to bring them down. That's kind of the big why story. I know it's complicated and it's a long story, but thanks for the chance to tell it.
Absolutely. So you take this extreme knowledge of concrete since you were 16, despite your desire not to be in the world of concrete.
Yeah.
And you marry it with this desire to, have an impact for the country and protection of people.
Sure.
Where does that lead you? We've talked a little bit about durability, but where does that lead you?
Sure. So where it has led me is to a company that produces a material that directly impacts durability of concrete, and that's my everyday job, is promotion of that particular product. Where it leads in the future, it's hard to say, but I think that right now, the product that I'm working with is one of the most important impacts. It can have one of the most important impacts to concrete durability of any technology out there, and that's why I'm with the company I'm with, is an opportunity to make a difference, an opportunity to really get on real job sites something that can help the concrete last a very long time. So that's where I'm at now. The future my vision, my why is I don't see it straying too much from that, is helping concrete last longer, regardless of the the mode of attack, if you will, whether it's environmental or man-made or whatever. So that's what I will always be striving for. and hopefully, I'd love to retire from the company I'm working for now.
Sure.
But we'll see. And my involvement with groups like the American Concrete Institute is also very valuable to me, because it's a gathering of like-minded concrete folks from all over the world.
Yeah.
And we get to be concrete nerds together. We get to talk about concrete, and there's some folks that like to show that they're the smartest concrete guy in the room, and it's always fun to get into debates and those kind of things. So that's kind of my fuel, is getting a chance to go see other guys that love concrete as much as I do and getting to talk to them. That's my fuel. My why is to help concrete last longer, and any way that I can do that is something I'll consider working on or working toward.
What are the things that you find people are most surprised about when you start talking about concrete?
Yeah, so if it's people that don't know much about concrete and they think of concrete as something you buy at the big box store in a bag on the shelf, then those folks will often just be amazed that I have a job doing what I'm doing, because they say, well, you're going to speak about concrete, or you wrote a paper on concrete, and you're going to go present it somewhere. Don't we already know everything there is to know about concrete? So the misconception that we understand concrete completely is the biggest thing that people are surprised when I tell them, no one knows everything there is to know about it. It's a topic that continues to give back to us, because the deeper you study it, the more you realize that you don't know everything about it, and we have a long way to go before we can truly understand all of the ways that the variables interact with each other.
One of the things that you keep bringing up is the durability of concrete. But I think it's important to note, you're not just talking about the durability from nature, you're also talking about the durability potentially from man-made events.
Yeah.
And it's now's probably a good time to bring up the diversion you had from concrete for a while when you went and got your degree in Homeland Security.
Yeah.
So the idea of creating a durable product regardless of the degradation is really essential to your why.
It is. Yeah, that's resilience is the word I like to use. Resilience of concrete structures regardless of the path of degradation, whether it's man-made environment, loading. That's my why. That's what I am most interested in, is figuring out ways to help our concrete structures last a very long time. I have friends all the time that ask me, Brent, the Romans obviously had it figured out. Why can't we figure out how to make our concrete last 1,000 years?
Totally, absolutely. Yeah, that's a great point.
Yeah, so, there's a lot of factors. I don't have a great answer for that question, but it starts with their exposure conditions to the environment that they're in is very different than exposure conditions elsewhere in the world. The Mediterranean environment happens to be a great environment to preserve concrete for
not exactly like South Georgia.
No, not at all. Not at all.
You bring up a great point. There's these incredible structures that have been around for, some of them thousands of years. And granted, they're in a little bit different environment sometimes than your projects. But are there things that we can learn about how we move forward in the future by looking into the past?
Yeah, definitely. One of the things that is really interesting to me is there's a group that has come up with an idea to use a agricultural waste product as their aggregate for their concrete, if you want to call it that. It's a Portland cement based cementitious system that doesn't have rock or sand in it. It is only this agricultural waste, and it has some really, really interesting properties. It's almost like wood. You can nail into it, you can drive screws into it like wood. It has flexural strength similar to wood. It has a modulus of elasticity nearer to wood than that of concrete, for those engineers that might be watching. So these kinds of materials are the next generation of cement-based materials. It's difficult to call them concrete because they're not traditional concrete.
Sure.
But they're using, in an innovative way, materials that are renewable. And because those materials are renewable, it is lowering the environmental impact of the structure. And it's going to last a very long time, because it just so happens that it's performing in a way that it doesn't require reinforcing steel.
Huh.
So reinforcing steel corrosion is one of the leading causes of concrete degradation. If you can avoid reinforcing steel corrosion by not having the reinforcing steel and still having the tensile and flexural properties you can increase the life. Yeah. So that's one of the things that's very interesting. And there's a wide range of agricultural waste that could be used. There's from things like rice husk to bamboo to coconut fibers even.
Wow.
Yeah.
So concrete is kind of getting a little bit of a revolution. We're going to be talking to Sam Flores, who's the director of Hugo, and their Curiosity Report. They're taking a look at concrete because of the potential it has to impact the carbon footprint. Tell me a little bit about that.
Yeah, so cement production, Portland cement, is one of the largest carbon gas producers in the world. I think it's behind only steel. And so we have this great material. But when we're making it, we're producing a lot of greenhouse gases. Now, the cement companies are aware of this, and there are several initiatives in place to reduce those carbon footprints by taking steps to include things like limestone into the grinding process and some lower impact materials in the cement making process. There are also initiatives to do things like use more supplementary cementitious materials, things like slags, fly ashes, biogenerated ashes, renewable resources that are sources of a supplementary material. Those kind of things are also initiatives. For me, though, I want to let you know that for me, the most important idea of sustainable concrete. Yes, it's great if we use recycled materials. It's great if we try to lower our carbon footprint for the initial, when we first make the concrete. Well, what's most important to me is that we begin making structures with the idea of durability in mind. We need to take life cycle of concrete seriously because we think of it as a permanent material. We think when we build a bridge or we build a building, we think of that concrete structure as it's going to be here for a very long time.
Right.
In reality, most concrete buildings have a life cycle of 50 to 60 years.
Sure.
There's some bridges out there, about 40% of the states right now have a life cycle on their bridge decks of less than 30 years. Wow. So when we look at concrete and how long it can last, wouldn't it be great if those buildings would last 100 years on average or 150 years on average? If we can start adjusting and the technology's there, we can do it now, and we can do it relatively inexpensively if we have the right mindset. It's important that we have strength. Concrete has to be strong to do what it does.
Right.
But it also needs to be durable.
All right, so concrete's obviously a nowhere near the only tool, but it's a very favorite tool of architects and engineers. If I'm an architect or an engineer and I'm trying to adopt that idea of moving from a 50-year life cycle to a 100-year life cycle, how do I impact that?
Yeah, so it has to do with managing the permeability of the concrete. So permeability, believe it or not, concrete is permeable. Most people don't realize. They think of that concrete's permeable. They think of it as a solid material because obviously, if you fall down off your bicycle on a driveway, it doesn't feel like a sponge or anything. But reality is that concrete has tiny capillaries and pores. And those capillaries and pores allow the movement of water and the contaminants that water carries, things like chlorides, sulfates, nitrates, other things that can attack concrete, freezing and thawing, those kind of things. So if we can reduce that permeability, we can keep the water and the contaminants that the water carries out of the concrete, then we can impact that durability of the concrete. And there's software models that are available that all rely on that permeability to predict how long concrete will last.
So then what are the unique characteristics of concrete? Why not just use a different building material that doesn't have the same carbon effect?
Yeah, that's a great question. The unique characteristics of concrete are that, number one, it can be cast into virtually any shape relatively easy. And what I mean by that is it takes on the shape of the forms that you use to place the concrete, especially with today's admixture technologies. There are high-range water reducers that allow even self-leveling concrete that's still strong and it still does what the engineers want it to do, which is to carry loads.
Right.
So it's very strong in compression. So we can build tall buildings. We can build large spans on bridges because the concrete is strong. Now, reinforced concrete brings in flexural tensile strength and things like that the concrete doesn't do well on its own. So the combination gives us a very versatile building material. So architects and engineers can use that building material to build virtually whatever their imagination brings to the table.
Sure. Are there specific things in addition to thinking through that life cycle and maybe even potentially doubling that life cycle of concrete?
Yeah.
Are there specific things that can be done on the manufacturing side that help with that carbon footprint? You mentioned limestone.
And
recycling.
Yeah. So there's a few different things on the manufacturing side. The material selection is going to be one of the most important aspects of producing concrete with a long life expectancy, because those raw materials can impact the permeability of the concrete. It all goes back to the permeability question. And there are nanomaterials on the market now. And ACI 241 Nanomaterials in Concrete is a committee devoted to reporting on different nanomaterials that are used in concrete. Things like colloidal silica, things like nano alumina, other carbon nanotubes are also used in some cases. So these nanomaterials are the next generation of permeability management in concrete for a couple of reasons. One, they provide seed or nucleation sites for the growth of the reaction products from the cement and water reaction. So, cement by itself is pretty useless. You mix it with water, and then it begins a series of chemical changes that allows it to harden and gain strength.
Right.
Well, as it's setting, as it's hardening, it needs the little places for those reaction products to grow, and the nanomaterials can act as seed sites to allow that growth to begin sooner than it normally would. So nanomaterials are one part of the future of longer lasting concrete. Just simply also the idea that we can't assume that concrete's durable. Too many people don't take durability when they design a building or design a pavement. They don't take durability into consideration at all. They're just assuming that, well, we have 4,000 PSI compressive strength concrete or 5,000 PSI, whatever the case may be, that my concrete's going to last a very long time.
Right.
In fact, we need to consider durability as a secondary, but still almost as important as compressive strength as a design element.
Brent, thank you so much for being here and having this curious conversation with us.
Thank you so much for the opportunity. I've really enjoyed it.
Thank you for watching or listening to this curious conversation, and make sure to check out the next episode of The Square.